So critical points, like we already talked about the intercepts, critical points are, gonna be your maximums, your minimums, and where we have a change in, direction or shape. Your extrema are always a change in direction. So extrema are your usually, most of the time they're your absolutes that we're normally talking about there. Your point of inflection is more of a shape change. So sometimes that point of inflection, like this one right here, we can still be going down, but it's an inflection point because the graph almost like turns sideways there. So it doesn't change direction there, it just kind of goes off sideways for a little bit. Okay, if we look at the point that has the greatest value in comparison to everything else, it's this point right here. It would be called, wait a minute, compared to points around it. Oh, it's local. Okay, it's going to be this one right here, your relative maximum. I had to reload that. So it's greater than the points around it, but it's not the greatest point. So the point that is the greatest, that would be this one over here, that would be an absolute maximum. And so on the other side of that, like this point right here is called a relative minimum, and then this one down here is an absolute. So the one that's a minimum in its general area, but not the furthest down, is relative. And then this one down here is an absolute minimum. Okay, so I do want to draw like a little picture over here. And I want to show you, so if you have like a cubic function, let's say it looks something like this, we're going to call that a cubic. So this point right here would be a relative maximum, and this point right here would be a relative minimum. When you have arrows going in both directions like this, there are no absolutes at all. So you can't have an absolute and an arrow in the same place. Like if you noticed up here where we had an absolute maximum, the arrows were both pointing down. And over here where we had an absolute minimum, the arrows were both pointing up. So if you have arrows going in both directions, it's an odd powered polynomial function. There's not going to be an absolute at all. Is that logical to y'all? Okay. Alright, so if we look at this, we're going to use your calculators to do this rather than, like we could, this one's pretty straightforward. We can tell what it is. So it would be an absolute minimum, and it looks like it's at 4 and -5. So that one's pretty obvious. But some of these over here, like they're not always super obvious, so we'll use your calculator. That's going to be your second trace. And you're going to select your minimum or your max option. And remember, just as a reminder, we only use left and right arrows there. So if we could do, you could do this, if y'all put this in your calculator, and we'll do them from left to right. It's the easiest way to do it. Lily, can you get this absolute maximum right up here? And then Catherine, can you get this relative minimum right here? And then Preston, can you get this relative maximum right there? And then I'm going to flip on the other side of the paper real quick. Rachel, you have your calculator? Will you get this minimum? I'm pretty sure I know what it is on this one. And then Antonio, will you get this maximum up here? Just save us a little bit of time on that. Alright, so we're going to get the absolute max, then we're going to get the relative minimum, and then we're going to get a relative max. And Preston, you had the, did you have the first one? No, Willie, you had the first one, right? The maximum, okay. And y'all just, we'll round those in, hundredths place. And you can give me your rounded number. Looks like it's about negative 1.5, I don't know exactly what it is, but it's pretty close. Negative 1.5, and what? 2.9, okay. Alright, Catherine, do you have the minimum?
Yes.
What you got?
0.3.
Okay,
Wait, and then negative 4.2.
negative 4.2. And your point two is rounded, yes?
No, negative 0.3, sorry.
4.3, okay, alright, no problem. Alright, and Preston, you have the next one?
1.2. What do you want to do?
Tenths is fine,
Okay, 1.2.
okay, and the Y value?
Negative 2.7.
Okay, alright, just wanna make sure everybody's comfortable getting those in your calculator. And we'll flip over. And y'all have those written down? They got them? Okay, alright, so back here, we had a relative minimum first. Alright, Antonio, what was that, baby? Oh, it was you, I'm sorry, what was it?
I got negative 3.2 and about negative 5.
Negative 3.2, negative 5, okay, and the relative max, Antonio?
Negative 0.3 and 4.4.
0.3 and 1.4?
4.4.
Oh, 4.4. Sorry, I just probably looked at that. Okay, alright, everybody's decently comfortable with that, yes? Okay, so on this one, we're not gonna sit here and find all these. I do wanna talk about like this location right here. So that guy is actually what we call a point of inflection. It's also a critical point. It looks like it's at 0.3 roughly is where it is. So you can, normally like we would find that in your calculator. We kind of go through the same process. I'm trying to think real quick. You can still use the minimum or the maximum. It'll still get you the same. It'll still help you find out. Everybody okay with that? Those don't happen real often. All right, everybody okay with those? Okay, so we're gonna talk about increasing, decreasing behavior. Just as a reminder, these are written in terms of X. So we're looking at it up and down, but we've gotta write it from left to right. These are ones, sometimes they can kind of throw you off, so we kind of have to be really careful. So if we look at this graph right here, obviously I'm increasing right here, and I'm decreasing here, and I'm constant at this area right here. So I'm gonna increase, this arrow is coming from negative infinity, so I'm increasing from negative infinity until I get to this X value, which is -1. And that is included, so I'm gonna draw it with the bracket there. Y'all okay with that? Alright, then I'm constant from, looks like -1 until 4, -1 to 4, and then I decrease from 4, and that arrow goes, even though it's going down, it's going to the right, it's going to positive infinity. Just be really, really careful with those because we write them for X, so the X is still going to the right, so it's positive infinity. Alright, good there? Okay. Alright, so here, we're just gonna write the intervals for increasing and decreasing. So this one is, and they always write increase, I think they list them increasing and then decreasing. I usually, if y'all remember, I usually write it in the order that I see it because that's how my brain works. So because this decreases first, I'm gonna write it first. Y'all do whatever you want, but I'm not gonna see how you do it. So, but I know it decreases first, so it decreases from negative infinity until I get to 3. And then it turns and goes from 3, and then it goes to positive infinity. So however y'all wanna work that out when you're doing it, it does not matter to me. This one right here, because this is a rational function, it has this asymptote here and here, even though sometimes it's not super obvious, but absolutely, when you see a function like that, you have to know that those asymptotes are gonna be there. So this is going down here, and this is coming down here, so it never increases. Everybody okay that it never increases? And since it never increases, I've gotta write a union on the decrease. Are y'all okay that we need a union on the decrease? Okay, so we're from negative infinity to -5. And then we're gonna union -5 back to infinity. Are we okay there? This one is an exponential function. It is increasing only, so negative to positive infinity. This one down here, it's a negative cubic. I already have these points, so I'm not gonna make y'all go find them for the purposes of time. Although this one's right here is pretty obvious, it looks like it's at 0. So we're gonna decrease from negative infinity to 0. Then we're gonna increase from 0 to, this point is 2.7. And then we're gonna increase from 2.7 to infinity. So like I said, I found those in advance, so you don't have to. This one right here, it's going to decrease first, so it decreases from negative infinity until we get to that x value, which is negative 1.7. Then it increases from negative 1.7 to 0 right here. Then it decreases from 0 to 1.1 is what I've got. And then increases again 1.1 to infinity. Are y'all okay with that one? Pretty typically how a x to the 4th is gonna do. Alright, this one, it does have an inflection point, so when we have this inflection like this is still decreasing all the way from here to here. So even though it kind of turns sideways, it doesn't start going back up, so it technically still decreases from this point all the way down to this point. Are y'all okay on how that works? Okay, so we're increasing from negative infinity to 1 there, then it decreases from, negative 1. From negative 1 until it gets to this point right here, which looks like it's at positive 1. And then it increases again from positive 1 to infinity. And those numbers may be slightly off, but that's close enough. Y'all okay on those?